In the deep, dark abyss beneath the Atlantic Ocean, scientists have uncovered massive, ancient structures that challenge everything we thought we knew about the formation of Earth's oceans. These structures are 117 million years old, hidden deep in the seafloor, and their discovery could rewrite the history of our planet. Imagine seismic waves stretching over a kilometer long and towering hundreds of meters high. These massive mud waves were created during the earliest stages of the Atlantic Ocean's formation, offering groundbreaking new insights into tectonic movements and how our world evolved millions of years ago. Led by renowned geoscientists Dr. Winston Nicholson and Dr. Deborah Duarte, the discovery began with an intense investigation into seismic data from the Atlantic Ocean seabed, located more than 3,000 feet below the surface, just off the coast of Guinea-Bissau, West Africa. This wasn't just another routine scan. The team was studying a region about 250 miles west of West Africa, an area where the ocean's past was buried deep beneath layers of sediment. The core samples extracted revealed something astonishing: gigantic sediment waves, some stretching up to 1 kilometer long and several hundred meters high, appeared to be frozen in time. And these aren't random formations. They were created by a powerful force millions of years ago, when Earth's tectonic plates began to split apart, leading to the creation of the Atlantic Ocean. So how did these enormous structures come to be? The answer lies in the ocean's early history and in something remarkably specific: salt-laden water. Before the Atlantic fully opened, tropical basins to the south of the equatorial Atlantic Gateway were drying up under extreme heat, leaving behind highly concentrated salt water, or brine. This dense water, heavier than regular ocean water, created an underwater flood of biblical proportions when the tectonic plates finally shifted and opened up the ocean basin. As this brine rushed northward, it triggered the formation of massive mud waves, much like a flood carving a canyon on land. The density of the brine allowed it to move with incredible force, reshaping the ocean floor. In doing so, it left behind a landscape of sediment waves that remain as evidence of this colossal event, towering, yet hidden beneath the surface. Until now, geologists believe the Atlantic Ocean began to open between 113 and 83 million years ago, a relatively narrow window based on other tectonic indicators. However, this new data from the seismic profiles and core samples pushes the timeline back by over 4 million years, suggesting that the birth of the Atlantic Ocean actually began as early as 117 million years ago. This significant shift in the timeline forces us to reconsider how we understand the tectonic processes that caused the separation of continents. As Dr. Winston Nicholson explains, the sediment waves uncovered by the team show that the opening of the Atlantic was not a sudden, catastrophic event, but a much more gradual process, one marked by powerful, yet focused geological forces. One of the most fascinating aspects of this discovery is the role that salt-laden water played in triggering this event. Picture this: vast salt lakes in tropical regions, evaporating under intense heat. The process left behind salt water so dense it became a force of nature. When the tectonic barrier cracked, this brine cascaded down the seabed like an underwater waterfall, carving massive sediment waves in its wake. This dynamic outflow helped form the ocean's basin, but it didn't just change the physical landscape. It also created a timestamp of sorts, an underwater signature of when the Atlantic Ocean began to emerge. These mud waves are the geological record of that exact moment, revealing a precise timeline of when saltwater first flowed through the ocean, permanently altering the planet's climate and ecosystems. This discovery does more than change the timeline of the Atlantic's birth. It challenges how we understand the forces that shape our planet. From tectonics to climate systems, the movements of the Earth's plates and the role of water in shaping the landscape are far more intricate and gradual than we once believed. These findings also provide crucial insights into the long-term effects of ocean formation on global climate. The creation of the Atlantic Ocean wasn't just a local phenomenon. It affected weather patterns, ocean currents, and ecosystems across the globe, setting the stage for the climate and biodiversity we see today. So next time you look at the vast expanse of the Atlantic Ocean, remember that beneath its surface lies a story that stretches back millions of years. A story written in mud waves, salt water, and tectonic upheaval, a chapter of Earth's history we're only beginning to understand.